All right, good morning, everybody. So, Chris and I will swap talk. So if anyone's confused, I'm not Chris. My name is José Valim. I'm the creator of Elixir. I asked Chris to exchange talks because I think he's going to do a much better job than I would do closing the conference. No pressure, Chris. And today, my talk's called Introducing HDD, and HDD stands for hard drive disks. No? So, all right, so let's get started here. So, as you're going to see, the title, it's kind of a play with words with something-driven development. But before we get to the bulk of the talk, let's talk a little bit about Elixir, how the last 6 months and 1 year, what has happened. And what has happened that time is exactly Elixir 1.6. So it was released January 2018. We've crossed 700 contributors. This was really nice. And the formatter played a really important job on that because Elixir 1.6, as we'll see, introduced a new code formatter, and we opened up for contributions for the community to format the Elixir code base. And a lot of people were able to get involved, and that was really fantastic. Many people get involved with Elixir for the first time. And we are reaching, at this point we probably passed 6,000 packages on HexPM over more than 175 million downloads, right? So it's good, like at least when we see everything code-wise, right? The community is growing, that's really exciting. And Elixir 1.6 has some very interesting features, nice features. So one of the features that come in Elixir 1.6 is the dynamic supervisor. So we always had a supervisor in Elixir, but it kind of had two modes, right? So it has the default mode where the tree would be static. When you define your application, you would define the tree and you know what the tree looks like. And then we would have a special mode called simple one-for-one, which was actually dynamic for starting children dynamically. And that was confusing because the documentation had conditionals, right? Like, oh, if you're using this function is going to behave like this, and if not, it's going to behave like this. And that's not a good sign. So we decided to get that, all the dynamic parts, we're going to put it under the dynamic supervisor, and we're going to streamline this experience. Another addition in Elixir 1.6 are two new attributes related mostly with documentation. So for example, here's a function that was deprecated in Elixir 1.6. We deprecated chunk in favor of a chunk every function that's a little bit more explicit, has better defaults. So what we did is that to the old function, which is the one you're seeing here, we say, well, this function exists since Elixir 1.0.0, but it's deprecated, and you should use it chunk every instead. So we are adding a little bit more annotation to our functions, and this is really good for us language developers and library developers, because now in future Elixir versions, when you publish this documentation, right, the users of our library can see exactly which version that thing was added, if it was deprecated. So the developers, you are going to get a lot more feedback on the API. So this is really nice. Another nice addition is def guard. So in Elixir, you could always define your custom guards. You would have to use macros, and they had a couple gotchas. So here's the example we have on our website today, right? We have this function where it says, I have a user. If the user is older than 21 years, we can serve drinks. And if you have this logic spread out for different places, right? What you can do now is that you can define a custom guard, and then you can use that in your functions, and that's going to reduce a lot of this repetition. But with no discussion, the biggest feature that we got in Elixir 1.6 is the code formatter. All right, thank you. So who here is already using the formatter? Beautiful, this is beautiful, thank you. So what the code formatter does, it formats code, right? So if we imagine that somebody wrote this very messy Phoenix controller where sometimes they use space after comma, sometimes they do not, sometimes they add extra lines at some weird places. The formatter is going to look at that, ignore almost all of the default formatting, and is going to format it according to a consistent style, right? And we are going to talk about it soon, a little bit more about the formatter. It's one of the big topics of this talk. Right? And that's how the language has improved since we last met. But other things that are not necessarily related to the language, but more with me personally that has happened and that I'm really excited about it. So one of those things is that we've written, and it just went to print like 2 weeks ago, this book called Adopting Elixir. So I wrote this book with Ben and Bruce. And what happened here, so we have many feedback cycles that we use to improve the language, right? Well, the topic of this talk is one particular cycle, which is a more academic cycle where we are improving the language based on that. But one of the cycles that I have been using to improve the language is my professional experience at Plataforma Tech. So for those who do not know, Plataforma Tech is the company behind Elixir, right? Elixir was born as a research and development project at Plataforma Tech. And since like the end of 2015, beginning of 2016, we have been helping companies use Elixir in production and help with development, all kinds of ways, right? And we were able to get a lot of experience from that. And some of the experience, right, we used to improve the language, improve the documentation, write more books, write more materials. But some of this experience, it was, it gets to a point where we streamline everything else and say, look, I've improved everything I could, but there's still a lot of topics I want to talk about, and they don't fit anywhere. So that was one of the ideas for this book, right? So I was talking with a bunch of different clients, and I was seeing that a lot of people adopting Elixir, a lot of companies, they were running into the same issues, right? And obviously, I want to fix those issues, right? And at the same time, Ben, who works at Bleacher Report, which is one of the early adopters of Elixir and running it at scale, he wanted to tell his story about how Elixir got to run at Bleacher Report. Then we went both to talk to Bruce, and Bruce said, let's write a book. And that's how the book came to be. So the book is about everything from your journey adopting Elixir, even from the beginning, from the concept, like, is this really the language for me? Right? Is this, am I going to find developers? Is the tooling good? So even from the concept of the idea of using Elixir and then up to development, what about distributed Elixir? What about adopting to functional paradigm? Right? So all those things, we have a bunch of reports and experiences, and then it ends with production. So it goes from concept to production. And in production, I'm going to explore how to deploy, how to coordinate deployments, logging, metrics, all kind of stuff. So I'm really happy with this book because I really think it's going to make a difference in the adoption of Elixir, right? Because all of the questions, many of the questions that you have every day, they're going to be answered there. So I'm really proud of this. And something else that has happened is that at Plataforma Tech, we're also launching a new service. Again, this feedback cycle, right? We are talking with companies. So sometimes the feedback cycle is about improving the language, is about improving the documentation. And we got a lot of feedback on how we can best serve companies at Plataforma Tech that want to get started with Elixir, right? So what we did was that many people, they want to have a way to continuously leverage the Plataforma Tech, my team expertise when building Elixir applications. And that's how we figure out how we could do it. So if you're interested, if you are adopting Elixir in your company and you'd like help moving forward with speed and confidence, just reach me out during the event. Go to the Plataforma Tech website, just make yourself heard, and they're going to figure something out, right? And as I was saying, so there are a bunch of things happening, improving at the same time, which is really great. And Elixir is going to continue improving. So we're expecting Elixir 1.7 in July 2018. So Elixir releases, they happen every 6 months. So we got one in January, we're going to get another one in July, and it's working like that for a while already. We don't know, right, like how many contributors we're going to have. We don't know the stats there, but what we know is that the big feature that we want to have in Elixir 1.7 is the addition of string data. So what is string data? String data is a data generation library. It's already available today, you can try it out. But in Elixir, when we add it to the language, it's going to look like this. We are going to have, so in Elixir we have the string module, which is about lazily applying transformations to collections, right? String data, it's the same idea, but it works on top of data type. So for example, after we import string data, now we have a bunch of generators like the integer generator here. where you can say, hey, give me 10 random integers, and it's going to spit 10 random integers for you. You can say, hey, give me 10 random ASCII strings, and it's going to spit 10 random ASCII strings for you, right? So that's one of the big additions. And you may be wondering, what is this for, right? We use this for writing property-based testing. So we are going to talk a lot about this, right? But today, the way we write tests is that we use examples-based testing, right? When you want to test a function, we need to stop and think about a bunch of different examples to test our code. With property-based testing, instead, we define a general property, or say, look, my code should work under this property. And then we let the properties generate all the data for us and test our code using a bunch of different inputs. And what is really interesting is that both the code formatter, which is the big feature that is coming at Elixir 1.6, and the string data that is coming 1.7, that Elixir code formatter came in Elixir 1.6, and the string data that's coming 1.7, the initial work, the initial foundation for those features was started on papers published by John Hughes. Okay, so John Hughes, he's Welsh, he's a professor at Chalmers University, and as you're going to see, the foundation that we use for the code formatter to work, the foundation that we use on string data, and even property-based testing altogether was initially written in papers published by him. And so that's kind of the talk right there, right? So introducing HDD, we are playing with the words here, right? With the driven development kind of thing. And here what we have is the Hughes driven development, where the idea is that if you want to improve your programming language, you wait for John Hughes, he's going to write a paper, you wait for him to write a paper, and then you wait like 10 years, sometimes even a little bit more, and then you incorporate those ideas into your programming language so everybody can profit. So there we go, HDD. So that's it, questions? So what we're going to do today is the following. We are going to explore both the code formatter and we are going to explore string data, but we are going to look into the code, how it actually works, and we are going to look to the papers that led to those ideas. Okay, so it's going to be more on the code side, on the implementation side of things that we're going to focus today. I'm going to briefly introduce those features before we go into the code. Talk a little bit about the rationale, but that's what we plan. All right? So let's do this. So the code formatter. So as we know, the code formatter, it formats your code using a consistent style, right? It helps you focus on what matters. So imagine that somebody sends a pull request, or you send a pull request and you get a bunch of feedback. And that feedback can be your coworker, or it can be a tool, a bot, a linter tool. But imagine that some of this feedback says, look, the line length limit is 80 characters, but here you used 82. And then another feedback says, the complexity of this function is too high, right? Which one would you like to address first? The complexity one, right? So the goal with the formatter is that sometimes a lot of the feedback that we get, they are all about style, code convention. And those, there is no reason for somebody tell us to fix it and then we go and fix it, right? We can have tools that are going to automatically fix it for us, and that's great, right? We want to automate that. So the code formatter helps you focus on what matters, because we no longer need to be talking about style guides, code decisions. Who here has been at some point in their career in a code style discussion? Right? So that's what we want to not have to focus on that and focus on what matters. And what I really like about this, and it's something that aligns really well with Elixir as in the way as we propose as a language and learning experience, right, is that the code formatter works as a really good guide for newcomers too. Because one of the things that you have to do when you're learning a new programming language is that you write some code and like, is this code idiomatic? Is that how other developers in the community would write this code? You have this question, right? And sometimes you send the code to a coworker or to a forum and ask for feedback on that. But now you have immediate feedback. You just run a command and then bam, it's there. That's how your code should look like. So you can learn how to write idiomatic code, right? At least in terms of style, as you're learning language as well, with a very fast feedback cycle. And it unifies code written by teams and the community. So this is really important, right? It's one code formatter for everybody. And we are going to explore it a little bit more. So just to drive this point home, right? So we had a official and non-official style guide for Elixir. We never had a official style guide because I was very against the idea that, imagine someone wants to contribute to Elixir and then we say, well, before we contribute to Elixir, read this like 500 lines, 600 lines document before. I don't think that's a very good experience. So we didn't have a official style guide that we would impose on developers, but we have a guide that we tried to follow internally and kind of documented the decisions that we did in Elixir. And what we did when the code formatter was ready is that I sent a pull request to the style guide to remove all of the rules that we no longer have to think about because we have the formatter. And we reduced the size of the style guide in half, in more than half. So this is really great. This is exactly what we want, right? So what are the code formatter principles? We have three principles there, right? So the first one, it does not change the code semantics by default, right? Because if the formatter changed your code, you would not be happy with that, right? So that's kind of the first rule. And I just say by default because we have a flag where the formatter can rename deprecated functions. So if you ask the formatter, hey, rename deprecated functions, so it can automatically upgrade your Elixir code to the latest and we rename the deprecated functions for you. So that's really nice. But we don't do that by default. You need to ask us to do it. And the other goal is to minimize configuration, right? Because if you have a bunch of configuration in the formatter, now instead of discussing about the rules, you're going to be discussing about the configuration. Oh, this configuration is better than the other, right? And then we don't want that to happen, right? So almost no configuration, that's the deal, that's what you get, okay? Deal with it. And then the third one is no special cases. Elixir was designed to be an extensible language. So we cannot say, oh, when you have this function, after this function, let's do this. No, that doesn't work because everybody can get Elixir and extend it in different ways. So we cannot have special case in the formatter. Right? So if you're not using the formatter yet and you want to use it today, all you need to do is to run mixed format. You need to have Elixir 1.6 and then you run mixed format in your project. And that's what it's going to format all your code for you. All right. So how does the formatter work then? So before we talk about the formatter, so here we're going to the implementation, right? This is the exciting part of the talk. So before we go about the code formatter, let's solve a subset of the problem. And what is a subset of the code formatting problem? Is formatting data structures. So when we are writing Elixir code, we have data structures, right? Those data structures, they're in memory. And we want to get the data that is in memory and print it to developers, as we can see here, right? So this is how we would understand a keyword list where with two keys, the first one is the key A with a child list of 1, 2, 3, and the second one is the key B with the value of a K, right? So imagine that we want to format it. So one of the things that we need to consider when we are printing, inspecting, formatting a data structure is the line length. So imagine that we have a line length of 25 columns here. Our data structure fits in that just fine. So we're like, okay, that's nice. I can print everything into a single line, right? However, if we say that the line length is of 20 columns here, then it doesn't work anymore. It's like we need to break this apart. So what we want is that we want to have some flexible formatting. We want to have some kind of flexible layout. So if in this case, because it doesn't fit into a single line anymore, what we need to do is that we need to break it over multiple lines, right? And if we reduce the line length even further, right, we need to say, oh, now I need to break this thing again, and then you go, as you reduce or you extend the line length, you need to flexibly format your data structures. Okay, and of course, if you reduce even further, then it gets to a point where we are going to go over the limit because there's nowhere we can break that thing further apart. So how do we solve this problem? We use something called document algebra. And the idea behind document algebra was introduced in this paper by John Hughes, where he calls the design of a pretty printing library. And what I really like about this paper is at the beginning of the paper, he says, look, we have this problem, printing data structures, right? Printing code. This is an old problem, right? Since we have higher level languages, we want to do this. So how can we solve this? And more importantly, how we can solve this functionally. Okay, so the idea that he had there is like, if we're going to solve this problem functionally, what we need to do is that we need to define a very basic set of data types, and we need to define a very basic set of rules where we can explore everything else, where we can build everything else on top of those very basic data types and on top of those very basic rules. So that's the algebra, right? It's the definition of those basic primitives where we're going to build everything on top. That's the document algebra. So it's a very interesting, when you read the paper and say, oh, like that's how they are functionally tackling a problem, how they are functionally tackling a domain. It's about data types and defining rules which are functions that work on those data types. So we have documents algebra. So what are the algebra is the rules, right, that we have on those documents. So what documents do we have? We have a text document. So here I'm using already the Elixir notation. That's how it works in the Elixir code base, if you're going to take a look at it. Right? It's not the same as in the paper, but they are very close to each other. So which documents do we have? We have a text document, which is a string, and a text document, we are going to print it exactly as is, right? So when you print a text document, it's exactly as is. We have the nest document, where you say, look, I want to nest this document by like 2 columns. And what this does is that if that document has a line break, we know that after the line break, we need to nest by 2 columns, and that's what it does. We have a line document, which means between 2 other documents, I want to have a line break between those 2 other documents. And we have the concat document that concatenates documents. It prints one right after the other. And finally, we have an empty document, which is empty, doesn't do anything, right? So, okay, so now we have our basic document. So let's see how we can print some data structures, okay? So imagine that we have a list. Imagine that we want to print that list on the top. So we have a list, 1, 2, 3, no spaces for simplification, right? So imagine that we want to print it exactly like that, everything into a single line. So what do? We start with opening brackets, and then we concat the first document as a text, right? The first document, which is the number 1 with a comma, the second document, number 2 with a comma, the third document, which is the number 3, and then we concat the closing brackets, and that's it, right? So that's everything into a single line. But what if we want to have each entry on its own line? How we would solve this? We would write this, right? So we would say, look, now I have the opening bracket, and then I have the line, and then I have another line document, but we want to nest everything that is inside the list. So I want to nest by 2 columns right after the number 3, right, the last document, and then I close the brackets, and that's it, right? So this is it. This is like the basic rules that we use for printing data structures. But we are not done, right? Because what we want to do is that we want to choose between layouts. We want to say, look, depending on how much space I have, I want to put everything into the same line, but if I don't have enough space, I need to break that stuff. And when we look at this, right, they're like, those things, they are similar, those 2 documents, right? It's like, kind of like replace concat by line or line by concat. But we have an issue here, right? Because in this line document, we have a call to nest, right? But in the previous document here, we don't have a call to nest, right? So they are really close to each other, like kind of just replace line by concat or vice versa. But we have this nest call, right? So the idea here, exactly the idea with having our algebra is figuring stuff out, like we can figure stuff out like this. Actually, in this document, if we add a nest call, it doesn't change the thing that's going to be printed because the nest call only has an effect when you have line breaks. So if we do this, if we just add the nest call, it means that swapping between those 2 documents is just a matter of, getting all the lines, all the line documents, and replace them by concat documents. And that's it, right? So we're really close of getting flexible layout. All we need to do is to say, look, I have this document, and this document has a bunch of line breaks in it. But if I replace those line breaks in it, and try to put everything into the same line, is that going to fit? If so, you print everything into the same line, otherwise you break it apart, right? So that's what we want to do. And when we went to implement this in Elixir for the first time, we used this paper called a Prettier Printer paper by Philip Wadler, which built on top of the John Hughes paper. And what I really like about this series of papers that they have, I really like their names, right? So in this case, a prettier printer, right? It's just because, as we see in the description of the paper, Philip Wadler, he was able to reduce the algebra a little bit further, so it's less code and it's also faster, right? And then he said, this is a prettier print, right? It's really nice. So from Philip Wadler, and the idea behind this paper is this. Every time we want to have a flexible layout, every time we want to choose like this goes into a single line or over multiple lines, you're going to wrap that into this group function, okay? So we introduced this new group thing. And the idea, and the way that the group function works is the following. I'm going to receive a document, so the group function is going to receive a document with a bunch of lines in it. And it's going to work like this. It's going to say, look, I'm going to receive a document here, and I need to choose between two documents. So the first document I want to try out is the same document where I replace all lines by concat. If that fits into the same line, I'm going to use that. If not, I'm going to use the original document with the line breaks. And that's it, right? So basically what this function is doing is that it's considering between those two solutions, right? Which one of those do we want, right? So if the first one fits on a single line, that's what we're going to use. Otherwise, we use the other. And we implemented that. So it was a pull request we received actually quite a long time ago because we have been using this for printing data structures in Elixir since, the pull request, you can see it was on the 11th of May 2013, so almost 5 years. And so it implemented exactly the Hughes Wadler document algebra. And then we started trying this out, and then at some point, Alexei, he left a comment there, like, let's do some stress testing on this. So what I did is that I think it was a 2 or 3 megabytes data structure. So I got this very large data structure, and I tried to print that. But when I did that, my computer was using like 100% CPU for 30 seconds, right? So if you try that, it's not going to take that long in Elixir, right? So something happened here. There was something wrong. And what was wrong is that both the Hughes and the Wadler papers, they were written for the Haskell programming language. And Haskell is a lazy programming language. So this code is very problematic in Elixir because it means every time you have a group, we are going to consider all the combinations at that moment eagerly. So it's exponential complexity. Let's understand that. Okay, so let's do a step back. Let's try to understand this issue. So we have this data structure, right? So we know when we have the line length of 25, it fits everything into a single line, but if you put the line length as 10, it compresses like that. So the question is, how many groups do we have in this data structure, right? How many groups? How many things that are able to break apart? We have 2, right? So we have the outer list, when we compress it a little bit, it breaks apart. And then we have the inner list, when we compress it even further, we are going to break it apart as well. We're going to render each entry on its own line. So the lazy versus eager here, what it means is the following, is that every time we have a group, the Elixir code, because it's eager, right, what it's going to do is that it's going to replace all the line by concats and try that out at that moment, and then try the other one out. And then if you have a group inside the group, so if you have 2 groups, because you're going to have a group inside another group, you're going to have 4 combinations to try out. If you have 3 groups, it's 8 combinations to try out, right? And we can see that as we add groups, so as the data structure starts to get nested and nested, the number of things we need to consider really starts to go really high. And that's why it was slow. So we got this other paper called Strictly Pretty, right? And again, the name here, it's really smart because we can say that Haskell is a lazy language, and Elixir, we say it's eager, but you can also say that Elixir is a strict language. So the idea of this paper is that, so Christian Lindig, he got the Wadler paper and he translated it to OCaml, which is a strict language like Elixir is, right? So that's strictly pretty. So he ported the algorithm considering the source of complexity here. So he ported the algorithm to OCaml. And Gustavo Brunoro, he sent a pull request building on top of the earlier pull request where he converts the algorithm to the Christian Lindig's paper, right? And the problem was solved. So in Elixir, we have document algebra. We have it actually for quite a long time, okay? And it's implemented by a module called inspect.algebra. And we use it to inspect data structures in Elixir, but since Elixir 1.6, we also use it by the code formatter. And the thing is, the code formatter problem is exactly the same problem. It's exactly the same thing. So imagine we have this code, right? And we want to format it. If we have 25 columns, it fits into a single line. Beautiful, right? But if we have only 20, we need to break it apart, right? And if we have only 10, we need to break it further apart. It's exactly the same issue, okay? But in order to support code formatting, we actually had to do some extensions to the algebra. So we had a little bit, some extra rules to make it work for us. So let's see some of them, some extensions. So the first one, it actually came for inspecting data structure, is the color document. That's why when you're using IEX in your terminal, the data structures, they come colored because we added the color document. Another document that we added was nesting by cursor. So before, you could only say, I want to nest this document by like 4 columns. Now we can say, I want to nest this document by whatever the cursor is right now. Another document that we added, and I'm going to show it as an example, is force and fit. And a couple other ones, right? So let's see one example, just the kind of changes we need to do in order for this algebra thing to support code formatting. Imagine we have this code, right? So in theory, for this code, okay, so we're calling some function named code. So we have the first argument is the atom, okay? The second argument is a here doc string, is a multi-line string. And then the third argument is some argument whatever, right? This code, it obviously fits in this line length here, this line limit. It fits, right? It's totally fine. But it looks weird, right? Because we have a multi-line thing in the middle of our function call. So the way we solve this in Elixir is like, every time you see a here doc, because it's by definition multi-line, we want to consider whatever is around it to be unfit. So basically what it does is that every time we have a here doc, we are going to say, look, this thing, even though it's going to fit into the line, consider as if it doesn't, because we want to break it apart. And that's it, right? That's the kind of rules we defined. All right, and that's it by the code formatter. So the idea here is, I mean, one of the interesting things is that now we all know a little bit about how it works, but I think one of the main takeaways that I have from the whole code formatting experience is exactly that, is this algebra idea, right? This idea where we can define very basic data types, very basic rules, and build everything on top of that, right? Because then you can address your whole problem domain with this very basic set of primitives, and that's a very interesting idea, and it's one that was there in the original paper. All right, so that's code formatting. It's already out there, you can use right now. Those are the primitives it's built on top. And then the second thing I want to talk about is what is coming in Elixir 1.7, as we saw, and is string data, right? And as we saw, we use string data for writing property-based tests, but the first question we need to answer here is then, why property-based tests, right? What are the limitations of the way we write tests today? And so what are the kind of tests we usually write today? Those are example-based testing, right? So what we do is that, for example, in the Elixir library, we have a function called string.contains. And one of the things that this function does is it checks, not one of the things, the thing that this function does is that it checks if the string on the left side, given this first argument, actually contains the string given the second argument. So in this case, it needs to return true. So when we implemented this function, we had to come up with a bunch of examples, right, to test. Oh, so imagine that I have the string full bar. I want to check that it starts with, that it has full in it, which it obviously has. So I want to check that, right? So we write this test, and then that should return true. And then we check that it also has bar in it, which is the end. And we want to test something in the middle, right? And then we want to check that it doesn't have something that it has. So we need to come up with all those examples, right? It's our responsibility as a developer, right? But then it brings two questions, right? So the first one, how are we going to find corner cases, right? Like, are we sure that we tested all the scenarios that are relevant for us to test, right? So how can we do that? How we can be sure, okay? And even if we find those corner cases, right? How are we going to reason about them? So let's see some examples. And we actually struggled with this in Elixir, right? So this, string contains. Should full bar contain the empty string? We need to remember that we need to test the scenario. And even if we remember that we need to test this case, we need to come up with a way of deciding, is this true or false, right? What should it be, right? We need to remember to test this case as well. does the empty string contain full bar? This one is easier, right? Like this empty string cannot contain something that is bigger than it, right? So this one is a little bit easier, but what about an empty string? Does it contain the empty string? Right, so we need to think about all those use cases. And sometimes we don't, right? And then we figure out those use cases as we go, or sometimes those use cases, the answer that you get, it's because it's tied to the implementation, right? Oh, it just works because that's how we implemented it for the first time. So sometimes when we refactor the code, the behavior changes because you never thought about that behavior in the first place. Now you change the implementation, the behavior was coupled to the implementation, and good luck, right? Now you change the behavior and you didn't even know it, okay? So every time if you're using an API and it says, well, if you pass this, it behaves like this. Or if you pass an empty string, it behaves like this, right? It's probably a smell, right? There is no underlying rule to how that function behaves. It was made up as you went along. Okay, so with property-based testing, we solve this issue because we just define the property, right? So what would be a good property for something like string contains? Here's what I want to do. So what I want to do is that we want to generate a string that is going to go on the left side, right? And then we want to generate another string that is going to go on the right side. And then we are going to concatenate the two strings together. So we have my final string is the concatenation of left and right. And that final string should contain both the left side and the right side, right? That's it, that's the property, right? And we can think, oh, something like string starts with, it's very similar, except we don't check that it contains the right side. So we came up with a property, and we don't have one property, sometimes we have multiple properties for the same function. And now that we have this property, what we do is that this property is using the code generators, the string data generators we're talking about. So we write this property and then we say, hey, now test this thing for me. Test that this property actually holds, this thing is actually true. So it's going to generate a bunch of random strings, right? And exercise our function using a bunch of different combinations, a bunch of different strings, a bunch of different values, right? So this is really good because now you're not thinking about examples, you're saying, look, this is how my code should behave, right? And then if for some reason the test fails, you know, like, oh, according to this property, right? Like, this thing should be true, so my implementation is wrong because I want my code to exhibit this property. So it also guides you towards the proper path, right? So what is property-based testing? So it's also described as generative testing. Although I don't like that name much, exactly because it's more than generating data, right? It's about describing the invariants of the system. It's about describing the things that should always be true. It's a property. It never changes. It's always true. It's a property, right? And when you think about it like that, right, it's going to lead you to thoroughly tested software that is designed with intent because you're no longer coming up with ad hoc rules about how this code should behave, right? There is a very well-defined and clear rule. And after we started using property-based testing more and more in Elixir, we actually found bugs in the standard library where we're actually inconsistent. Depending on the input, our code did not obey a certain property. Okay? So and how did it all start, property-based testing? It started with this paper by John Hughes and Claessen called QuickCheck, a lightweight tool for hand-on testing of Haskell programs, right? But this time, and that's why we decided to implement for Elixir, we have other implementations available even for Elixir and Erlang. We decided to implement something that we can build into the language and really leverage the existing string features that we have in Elixir. That was our goal. But it was based on this paper, right? But this time we learned our lesson, right? Because when we converted the pretty printed papers, right, which were written for Haskell, later we found out that everything was slow because Haskell is a lazy language and Elixir is eagerly strict, right? So this time it's right there in the title. They're like, haha, you're not going to get me again. So we knew that we cannot just port this paper. We need to do something different. And one of the things that we used a lot to drive our implementation was really helpful was exactly the implementation for closure, right? So for the pretty printer, we, based on the Ocaml implementation, this time really leverage the closure implementation called test check, and we build on top of that because it's an eager strict language as Elixir is, right? So how does it work, right? So let's look at the internals very quickly. How does it work? How does the data generators work? So what are generators? As we said, they are all defined in the string data module, and the generators, there are those functions like integer here, right? Or the string passing the ASCII parameter. And we ask it to generate a bunch of data for us, and they do that, right? So what are generators? So they are lazy. First thing, they are lazy. So if you call the integer generator in the command line, it's going to return this thing. And this string data thing is just a recipe of how to generate data. It doesn't generate data quite yet, but it knows how to. It's a recipe. The same way that the stream module in Elixir works, right? It's just a recipe. And the generators, they are infinite. So if you say, I want to convert the generator into a list, it's going to take forever, right? Because it's going to keep generating things as long as it can, right? It doesn't take forever because it don't have infinite memory. So eventually you run out of memory, but for all purposes, it's going to take forever. And generators, so they are infinite, so they keep on generating values. But they are also random. Every time you invoke the generator, the same generator, you're going to get different values out of it. And you can see that those values, they're not guaranteed to be unique, right? You get duplicated values, even the same invocation, okay? Another thing about the generators that makes them really interesting is that they grow in size. So imagine that we have this integer generator and say, hey, I want to skip, so let's take a step back, right? So we can see here that those generators, they're generating small numbers, right? Like -1, 1, 3, 5. But what happens if we say, I wanted to skip the first 100 elements and then generate 10 for me? You can see that the numbers now, they are bigger, right? So we are generating 100, -71, and so on. So the amplitude grows as you generate more terms. And that's what we want, right? Because if imagine that we are using this, for example, to generate tests for us, for property-based testing. As you generate data, the longer you allow that test to generate, we are growing the size of the inputs that we are using to test that, right? So, the generators, they grow in size. And the other nice thing about generators is that they are shrinkable, right? So what do we mean that generators are shrinkable? Imagine that, for example, imagine this test here. Imagine that we write this test, this property that we want it to fail, okay? We want this property to fail. It's a failed property just for us to test how our code works. So what we're doing here is like, so we have the property where we want to check where the element is not in the list. So we say, look, I want to generate a list of integers, right? And that's going to be my list. And I want to assert that 22 is not in the list, okay? So this is going to eventually fail because since we are generating random lists of integers, eventually you're going to generate a list that has 22 in it, and that's going to make the test fail, right? But what is going to happen is that as the test runs, because the generators, they grow in size, right? As the tests run, the lists, they are going to get bigger and bigger, and the numbers are starting to get bigger and bigger. So when this test fails, you may have a very big list. You may have a list with 20 elements, right? And then here we know that the reason why it fails is because it has 22 in it. But in your actual code, what could happen is that the test would say, look, the property failed here, right? When you pass this very large list, and then you look at it and say like, wait, what is in this list that is making my test fail? What we have here that is making my test not pass, right? So what do we do, right, in those cases? We actually, so every time you have a library, every time somebody reports a bug in your library, what are one of the things that you ask them to do? Do you have a minimal reproducible case of this bug so I can try it out, right? So the generators, they know how to do that automatically for us because they are shrinkable. So what we do is that for this property, when it fails, string data, the generators, it's going to say, hey, I saw that this failed. Let me see if I can shrink and I can find the minimal input that is going to make this test fail. All right, and then it can do that. So, so it says, for example, look, I have this property, and I tried 29 times. I generated 29 different things, and it worked. But at some point, I generated something that made it fail, and I was able to shrink it. So you can see here that when the list is a list with a single element and has the number 22 in it, right? This thing fails. Right? So because it tried 29 times in the past with success, there is a chance that the list at this point actually had 30 elements, right? Because the list is going to grow as you generate. So, but we're able to shrink it. We say, look, this is the minimal thing that is going to make this property fail. And this is really, really useful. So there is there is one presentation, actually it's a video on YouTube. If somebody remembers, I think it's from Computer File or something like that, the channel where they got John Hughes. And he's using property-based testing to find, and when he was using property-based testing to test an implementation, I think it was a communication protocol for a car manufacturer. He actually found a bug in the protocol, right? The way they encoded the protocol, you could find properties that would always be false. And then there's nothing you can do, like the whole specification has a flaw, right? But you're able to find this flaw on the specification using some particular implementation, right? And when you're testing something like that, you don't want to have a huge input, right? You want to have the minimal input that says, look, even with this minimal thing, I could find a flaw in your specification. Right, so that's really fantastic. I'm going to tweet out the episode later because it's really fantastic. It's a really very good use case for property-based testing, right? And okay, so we know all those properties about generators, right? We know that they're lazy, we know that they're random, we know that they grow in size, we know that they can shrink. But at the end, what are generators then? Generators, they are just functions, right? A generator is a function that receives two arguments. So the first one is the seed that we use for random number generator. And the second one is the size that we grow as we generate things. And the generator needs to return two things, right? So it returns a tuple with two elements. The first element is the current element that you just generated. And the second element is something that knows how to reduce, how to shrink that thing in case that value fails, right? So that's the simplification of how they work internally. So that's it. So we want to bring stream data into Elixir. Right? It provides data generation primitives, and we are using those data generation primitives to bring stateless property-based testing to XUnit, right? And here I'm using the word stateless because the discipline of property-based testing is actually a big discipline, and we are having only a subset of those in Elixir. But that's what we want to do, right? We want to get everybody excited about this thing, everybody to start relying more on property-based tests, right? And then if you start doing that, if you want to use the more advanced tools, you're going to be able to, right? Because you already had the introduction in a very familiar environment, right? So for example, QuickCheck, which is, so remember the paper by John Hughes called QuickCheck, and that became actually a product that they have, the open source version and the paid version, and we have it available for both the Erlang and the Elixir community. So if you want more advanced tools, right, you can check out QuickCheck, for example. It does model checking. It actually does, like, if you have a complex model, it tries to mess up with your scheduler, so you try that thing concurrently and explore different things. So there's a bunch of interesting stuff happening there. Right, so that's it. We got to the end of the talk, right? So that's Hughes-driven development. And the idea here, again, is exactly, you know, we have the cycle of academia where you have new ideas being introduced, and then we, with time, incorporate those into the language. And this time I call it Hughes-driven development, right? But the truth is, it's much more than that, right? So even when we're talking about code formatting, so Hughes published the initial paper, and then Wadler improved it, and then Christian Linding improved it, and that's how it goes, right? It's a bunch, everybody's iterating and improving everybody's work, and sometimes the idea is improving academia, and then it comes to industry, we improve a little bit more, and then academia brings it back, try to rationalize our improvements, try to make sure that they are sound, that they are safe, right? And then it goes back to us. So it's a very interesting cycle, and I think these particular two ones are very interesting because those ideas, they exist in academia for a long period of time, and now they're really becoming mainstream, right? Code formatting, we have a bunch of different languages that are actually using that. I'm not sure if they're using the same basic primitives of document algebra that we see here, right? But it's really getting more mainstream adoption, and the same for property-based testing, right? Elixir is adding it, but we have libraries for many of the major languages that we have out there. So I want to thank John Hughes for all his contributions. So I want everybody to... It is a great feeling to, you know, to have a problem and somebody wrote a paper on how to solve that problem. So it's really great. And as I said, it's a bunch of academia actually working together. But we are using two main examples from John Hughes today, and that's why I want to thank him. I also want to thank this work to get into Elixir. It actually required a lot of work from a bunch of different developers. So for the code formatter, both code formatter and stream data, I want to thank Andrea Leopardi. He's in the Elixir core team, and he's going to give a talk on stream data tomorrow, if I'm correct. So check it out. And so for the code formatter, we also have Alex Zhao. He was a Google Summer of Code student that helped us really push this thing forward. There is Louis Pifaud. He's the one that braved and the first person to write a code formatter in Elixir, and we use his feedback in there and to take the correct decisions. And for stream data, I also want to thank the closure test library, which was really provided the foundation that we are building our own generators as well. And finally, I want to thank Platform Attack. And we would not be here if it was not Platform Attack and all this time that we have invested in the Elixir and in the community. So all my work, right, it's part of my work at Platform Attack, all of the work that I put towards Elixir. And I want to thank the rest of the Rails part. Oh, Rails, Jesus. It's a habit, but sure, I do thank them because they got where I am right now, right? So it's that really appreciated, but I also want to thank the Elixir core team, right, for all the support, and I want to thank everybody for being here and everybody who tried the code formatter, contributed to it, and tried stream data and giving us feedback. So thank you, everybody. I hope you have a great day.
A huge thanks. Huge thanks for that. But there is one more thing. So you don't get to go off stage quite yet. I believe that our friends from Claessen has a little something for you. Welcome up.
Good morning. Wow, that's loud. Nice. I'm Florian from Claessen. You will hear more about this tomorrow, actually, where I will give you the full 2-hour presentation. It'll be super exciting. I'm going to talk about Steel. But on behalf of my team, and I think on behalf of the community, I would like to thank you for all the hard work you've been doing over the years. And I've discussed with my team like how to properly thank you. And at Claessen we're really into 3D printing. And we got this really large 3D printer, which is A, super loud, and B, super cool. And we just thought of something. So bear with me here, and I hope you have the necessary arm strength, because I know I haven't. Oh my god. I'm going to do the presentation now. This is 16 kilograms of polymer. Sleek. It's really cool. If you want to know more about like all our shenanigans, like with 3D printing, or if you just want to touch that logo, just come by our booth. We'll explain all of that. If you're a speaker at this conference, there might be some polymer for you. All right. Have a great conference, you guys. See you tomorrow.
I do believe.
Hi there, thanks for the presentation. I was wondering if there are some other papers from John Hughes that will inspire Elixir in the near future.
That's a very good question. So we have, like over the last weeks, Andrea, we have been talking about and a couple different approaches that we may explore about like how to best generate data. So for example, we have a tree generator in stream data that's supposed to generate a tree, but the trees that we generate, they do not have a good property, or they are either too flat or they are either too long, and we want to kind of be in the middle. And apparently it's actually a very hard problem to solve. And so we are reading a bunch of different papers, and John Hughes' names is like half of them are going to find his name. So I'm pretty sure, I don't have an exact answer right now, but I'm pretty sure it's bound to happen.
Do you have another question?
One last question? All right.
There you have one. I knew I could count on you, Martin.
Hi. So the whole idea of property-based testing, I love that it's coming into the core language. And I guess we'll all have to learn how to write our properties, because I noticed on the slide, like you did mention you'd write several different properties, but the slide you had, you know, if I were, you know, the kind of evil TDDer that I am, I'd implement, you know, contains question mark as true. So, like, how do you think about the negative cases for properties?
Can you repeat the last part? How I think about the?
So, for example, string contains, right? And I want to have a property that also says that I can refute that this string contains this other string, but like I have this random data, maybe I'll get, you know, a string that actually contains the other string. And like, how does that work when you generate the data? The data has to have some sort of, you know,
Yeah.
relation.
So I wrote the code, right? Like, so the example had check call here, and then inside the do block you can do whatever you want. So you don't need to use assertions, you don't need to use refute, you can do whatever you want. So although we do not recommend, so for example, if you say, well, there is a particular kind of input that this code does not work, you could, for example, say, I don't want to run any test at that moment, for example. And you just put all the assertions in a conditional block or whatever test library you're using. But you want to avoid that, because then it means that your code is no longer true for that property, right? You're kind of like poking holes in it. And so we want to avoid that, but if it's something that for some reason we really need to do it, it's possible. All right, so thanks everybody for the questions. I will stay around, so if you want to talk about anything, just hit me up. If I did not answer one of the questions properly, also ping me. I'll be glad to talk about those things as well. Thank you so much.